All right, kids, so now we're going to do some word problem applications. I'm just going to walk through a couple of them on the video, and we'll practice some in class. It's really not any different than what we were doing before, solving quadratic equations, just now we're applying it to word problems. Okay, so this is kind of a classic parabolic motion one where the diver is standing on a platform 24 feet above the pool. He jumps from the platform with an initial upward velocity of 8 feet per second. Because a lot of times, if you watch divers, they usually jump, especially like in the Olympics, stuff like that. They jump up first and then go ahead and do their dive. And then here is a formula that expresses the diver's h height above the water, okay, in terms of the information given. So here it says h is the height above the water. T is time, that's time in seconds. V is the upwards, starting upward velocity, and you see that was given to us as 8. And S is a starting height, that's 24. So we know what V and S are because they gave us V as being 8 and S as 24. So there's actually just one variable here, in this case, the T. So this first question, what will the height be after 1 second? So you have to ask yourself, what are you being given here? What are you being told? And then also think, what are you being asked for? Well, here you are being told 1 second. You are being told the time, and you have to find the height. So this is really simple. All we have to do is just plug in to this equation. We are being told that the time, t, is 1, so I'm going to put that in for t. I was told that the upward velocity v was 8. Remember, t is 1 here in this problem. And then my starting height is 24. So now I just take my calculator and crank this out, okay? And type in this string of stuff, and you will come up with 16 feet. After 1 second, the diver's at a height of 16 feet, okay? So that's pretty simple. It's this next one that's a little bit harder. See, again, ask yourself, what are you being given and what are you being asked for? Here it says, how long will it take for him to hit the water? So they're asking us to solve for the time. So we don't know what the time is. Time is still going to be, is just going to be t. Now, the secret here is you got to think. So, well, watch this. Negative 16, we're solving for time, so time is still t. So t squared plus, remember the upward velocity was 8, and then there's a t there. I'm just using this formula. The starting height was 24. Now, what's the h? Let's think about this. H is the height above the water. So how long will it take for him to hit the water? When the diver hits the water, what is his height then above the water? And I'm hoping you're thinking 0, right? When the diver hits the water, he is not above the water anymore. His height is 0. So now we have a quadratic equation that is set equal to 0 for us. And that's what we've been doing here now, right? Remember, the first thing that we do with a quadratic equation, oh, well, we're going to solve this by factoring. But before we do that, I don't like this negative here. I don't like it for any of my students to have to solve a quadratic equation when the leading coefficient is negative. So we can multiply both sides, because whatever I do on one side, as long as I do it on the other, that's okay. And if I multiply by a negative, that'll change to a positive. Now, negative 1 times 0 is still 0, but this is now going to be 16t squared. But now I have to multiply everything over here by negative 1. So that's minus 8t, and that's minus 24. Now we can go about and solve. Take out the GCF. The GCF here is 8. So we're left with 2t squared minus t minus 3. Now we have to set up our double parentheses. Only factor pair of 2 is 2 and 1. Only factor pair of 3 is 3 and 1. 3 is going to have to go there because you see that makes 3 and that makes 2. And together 3 and 2 can make 1. I just got to get the signs right. This means that the signs are different. This means that the bigger one, in this case the 3, is negative. So I get two answers. I get -1. And remember, the shortcut for this is this over this, change the sign. So I get 3 over 2, which is the same thing as 1.5. Now, if you forgot how to do this, remember 2t minus 3, we're set that equal to 0. We move the 3 over, and we get 3 over 2. Now, we're not quite done yet, though, okay? Because think about, what does t stand for in this problem? T stands for time in seconds. And no matter how badly sometimes we want to, we cannot go back in time. This answer of t equals -1 makes no sense. So we cross that one out. And our answer is going to be 3 over 2, which is 1.5. It takes the diver 1.5 seconds to hit the water. Okay? The -1 is what we call an extraneous solution. We toss that. A rectangular poster has an area, so we got one more problem to do here. Now, we've done stuff like this before, okay? Remember, define your variable for what you don't know anything about. It says the height of the poster is 1 inch less than twice the width. We don't know anything about the width, right? So I'm going to call that W. W is the width. Now the height, remember it says 1 inch less than twice the width. So that would be 2W minus 1. Remember, less than, that means you're taking 1 away from something. So there's our little diagram, helps us visualize. And now we can set up an equation. Remember, we're given that the area is 190. Area is length times width, or base times height, same thing. So it will be W times 2W minus 1 equals 190. Now, the mistake that sometimes students make is they say, oh, well, W must be 0, because that's what's the answer is when you have a W in the front. And then this one would be this over this, change of sign, 1/2. But remember, this isn't set equal to 0. We have to set this equal to 0. And I'm going to have to distribute here. So I get 2W squared minus W. Now, to move this over, I would have to subtract it. And now I'm set equal to 0. Now, this one's a little bit harder to factor. There is no GCF. The only factor pair of 2 is 2 and 1. Now, this 190 is kind of big. Turns out it's 19 and 10, because you see this gives me 20, and this gives me 19, and 20 and 19 can make 1 if you subtract. This tells me the signs are different. This tells me that the bigger product, in this case the 20, must be negative. So I get answers of 10, and I get answers of -19 over 2. But remember, it would make no sense to have a width of a poster that's in negative units. So our width is 10. We're talking about inches here, so it's 10 inches. Now remember, the problem's asking for the dimensions. So this is 10, and then if we plug 10 in here, 2 times 10 is 20. 20 minus 1 is 19. So the final answer is 10 by 19. 10 inches by 19 inches. That's the dimensions. So this is, using skills from before. You define the variable for what you don't know anything about. It's just that now you're setting up a quadratic equation, and then you're using the skills that we've been working on here these last couple of days. And we solved in this case for W, but in the previous one we solved for T. It depends. All right.